It's been dormant for 640,000 years. But is it time to start worrying about Yellowstone National Park blowing its lid? What would happen if this supervolcano actually erupted? Could life as we know it end? Now that the United States has begun fracking operations near the park, some scientists say the chances of an eruption are higher than ever. And by the way, when I say the United States, I mean the state of Montana, because that's where the drilling company intends to dump the toxic wastewater from the process onto the ground. But even if they don't find anything worthwhile in Montana, the Yellowstone Supervolcano still poses a threat to the entire planet. So let's talk about what exactly makes it so dangerous. What do we mean when we say it's a supervolcano? How likely is an eruption? And if one were to occur, what effect would it have on our world? Yellowstone is located in the northwest corner of the United States, straddling the border between the states of Idaho and Montana. It takes up almost all of Yellowstone National Park, which was created in 1872 and is the world's first national park. The park itself covers an area of around 9,000 square kilometers, but the Yellowstone Caldera, also known as the Yellowstone Supervolcano, covers an area of around 43,000 square kilometers. That makes it roughly the size of Belgium or a little smaller than the U.S. state of Maryland. This huge crater was formed by the immense explosive eruption of supervolcano 640,000 years ago, which ejected an estimated 2,500 cubic kilometers of ash, rock, and pumice into the atmosphere. This is equivalent to 1/50th of the total volume of water held in Lake Superior, the largest freshwater lake in the world. Or, to put it another way, the explosive force of the blast was over 2,000 times greater than that of the 1980 Mount St. Helens eruption in Washington state. The sheer scale of the event resulted in the formation of a gigantic caldera stretching 43 by 28 miles or 69 by 45 kilometers across. Over the following centuries, the land began to rise again, eventually forming the Yellowstone National Park we see today. And while there have been much smaller eruptions since then, there hasn't been another big one. Until now, scientists had assumed that the next large eruption wouldn't take place for another 300,000 years at the earliest. However, recent studies indicate that the interval between major eruptions may be far shorter than previously thought. Yellowstone has a history of catastrophic eruptions that have shaped the surrounding landscape and affected the global climate. There have been 3 periods of intense volcanic activity, known as the hotspot, each separated by relatively calm periods. During these hotspots, magma generated deep within the Earth's mantle steadily built up and forced its way to the surface. The first period began around 2.1 million years ago, creating the Yellowstone hotspot track. Magma produced during this time was highly viscous, resulting in the formation of lava domes and flows. The second period started about 1.3 million years ago, with magma becoming less viscous and more fluid, leading to the development of vast outpourings of flood basalts. The third period began around 640,000 years ago, marked by a significant increase in explosivity. The eruption of 640,000 years ago was the most violent, creating the Yellowstone Caldera. Interestingly, the magma chamber beneath Yellowstone isn't particularly deep, typically located only 5 to 10 kilometers below the surface. Scientists believe that this shallow magma chamber is responsible for the increased frequency and intensity of eruptions in the past 650,000 years. There are several theories attempting to explain why the magma chamber is so shallow. One suggests that a plume of hot rock material known as a diapir rises from deep within the Earth's mantle, melting the rock above it and creating a channel for magma to ascend along. Another theory proposes that the movement of the Pacific and North American tectonic plates may have caused the thinning of the lithosphere, allowing the magma to reach the surface more easily. A third explanation involves the presence of a mantle plume, a column of hot rock rising from deep within the Earth's interior, which could potentially contribute to the formation of shallow magma chambers. Scientists use various methods to study the structure and composition of the Yellowstone caldera and magma chamber, helping them better understand its behavior. Seismic tomography, which involves analyzing the speed of seismic waves through the Earth's interior, provides insights into the structure and composition of the caldera. By recording the time it takes for waves to travel through different parts of the Earth's layers, scientists can create images showing variations in density and temperature. These images help identify areas of high temperatures and low velocities, indicating the presence of magma. Another technique used is gravity measurements, which can detect subtle variations in the Earth's gravitational field. Changes in gravity can help identify buried masses or voids beneath the surface. For example, an increase in gravity could suggest the accumulation of dense magma, while a decrease could indicate a void or a magma chamber. By monitoring changes in gravity over time, scientists can track the movement and changes in the mass distribution beneath the Yellowstone caldera. These techniques allow scientists to monitor the Yellowstone Supervolcano's activity and better understand its behavior. They continue to analyze data and refine their models to improve our understanding of this fascinating natural phenomenon. According to a study published in the journal Quaternary Science Reviews, the probability of a massive eruption causing substantial damage in the next 1,000 years is estimated to be around 1%. However, other scientists argue that these probabilities are too low and that the potential consequences of such an eruption are too severe to ignore. Currently, the United States Geological Survey is closely monitoring any signs of increased activity. As part of their efforts, they maintain a network of seismographs in the region to detect any changes in seismic activity. Any unusual patterns could indicate pressure changes within the magma chamber, providing clues about potential unrest. Geologists also monitor ground deformation using instruments like GPS and INSAR, interferometric synthetic aperture radar. These tools help detect even the smallest changes in the Earth's surface, providing insights into magma movement and potential caldera uplift. Additionally, scientists keep a close watch on gas emissions from the supervolcano. Changes in the composition or volume of gases released could signal increased magma chamber activity. By continuously gathering and analyzing data, scientists aim to identify any signs of heightened volcanic activity and assess the potential risks associated with the Yellowstone Supervolcano. What happens if the Yellowstone Supervolcano erupts? Its impact would depend on factors such as the magnitude of the eruption, the nature of the volcanic material, and prevailing weather conditions. Ash and fine particles could be lofted into the stratosphere, blocking sunlight and disrupting global climate patterns. Pyroclastic flows and lahars pose threats to nearby areas, while the collapse of the caldera could trigger earthquakes and tsunamis. In the immediate vicinity, evacuation orders would be issued, and local infrastructure and agriculture would be severely impacted. Evacuations would likely extend hundreds of kilometers away from the volcano due to the danger posed by pyroclastic flows and ashfall. Ash clouds would spread across the northern United States and Canada, disrupting air traffic and affecting air quality. Fine particles could be carried around the globe, potentially altering weather patterns and temperatures. Residues left behind after the eruption would cover vast areas in the western part of North America. Pyroclastic flows would destroy everything in their path, incinerating forests and incinerating buildings and burying towns under hot ash. Lahars, which are volcanic mudflows, could further damage infrastructure and agricultural lands, affecting food production and supply chains. A major eruption would have worldwide effects. Ash and gases released into the atmosphere could block sunlight, leading to global cooling and disrupting climate patterns. Countries heavily reliant on agriculture would face food shortages. Global supply chains would be disrupted due to transportation issues and economic downturns. The recovery process would be lengthy and challenging. Decades would be needed to restore ecosystems and infrastructure. Economic recovery would depend on global cooperation and resource mobilization. Psychological impacts from the disaster could affect individuals and communities for years. Yellowstone National Park is a remarkable natural wonder with a rich history and ongoing scientific significance. While the potential impact of a super eruption is concerning, it's important to note that such events are rare and scientists closely monitor any signs of heightened activity. Preparedness and international collaboration are crucial for effective response and recovery in the event of a major eruption. So how worried should we be? Probably not that worried. Even if it did erupt, there are lots of warning signs beforehand, and you'd need to be pretty unlucky to live in its direct path. Anyway, I'm not qualified to give an opinion either way. I just work here. Thanks for watching. If you liked this video, please consider supporting us.